Hello everyone, my name is Vlad Romanov with SolusPLC.com, and if you have been following our live streams on the Manufacturing Hub with myself and Dave Griffith, you probably remember a guest that we had not too long ago by the name of Preston Hadley. Now, Preston has had a very interesting event which was called the Change a Life giveaway, where he essentially donated a Siemens PLC and HMI to an individual who was looking to get into the space. Now, what we have agreed upon is that once Preston is going to set up a second giveaway, Solus PLC would get a little bit involved and try to promote that event, because we do believe that a cause is worthwhile if it teaches somebody something out there and allows them to get hands-on experience with some of this hardware and software. Now, one of the vendors that we were surprised to hear from is Festo, and the reason I say that is because Festo is traditionally known, or at least by many of the automation engineers, is known for their pneumatics. So they provide a lot of different valves, solenoid banks, and everything that has to do with essentially controlling air. That being said, Festo has a lot more to offer, and one of the surprising things to see, for me at least, from Festo is servo drives. So in this box I have a servo drive that's going to be part of the giveaway, but what we've agreed to do is, over the next couple of episodes, we're going to take a look at the drive, we're going to integrate that into an Allen Bradley PLC, and ultimately I think it's a very good solution not only to learn from, but also to implement in industrial facilities. So without any further delay, let's unbox to see what we've got in the kit. I'm also going to be posting some of the links if you want to purchase this for yourself, either, like I said, for learning purposes, or if you want to implement that in the field. And then we're going to look at the hardware and software that is required to set this up. That being said, when it comes to the giveaway, Preston will announce the details shortly, so you'll have to stay put, but we will be spreading them across Solus PLC as well. So if you're subscribed, if you look at the channel, if you receive our newsletter, that's going to be one of the places to look out for the announcement of the giveaway. Alright, so here's the Festo package. As you can see by the label, it is the CMMT-ST-C8-1C-EP Ethernet IP based servo drive. That being said, they do have different options available, so it's not only Ethernet IP, you can also get it in other flavors if you're working with Siemens PLCs, for example, but this is going to be specifically for an Allen Bradley configuration that works over Ethernet IP. We do get a manual, so service and support, both in German and I believe in English. I have not opened this myself yet, so there's where you can get the different drivers, the kits. We're going to look at that in just a second. First and foremost, we do get a cable, looks like some kind of an I/O cable. I'm not sure if anybody's curious about the model numbers of these. We're just going to set them aside for now. And then we've got what looks like a serial cable, so a DB9 to just pins. I'm assuming that's going to have to go to the servo. We do have an instruction manual that appears to be only in German from this, but we're going to open it up as well. And here are the two actually interesting pieces, so I'm just going to put them out of the box. As you can see, there's not much else other than that. And so let's open the servo first. I'm assuming this is the servo, so stepper motor, as you can see here, EMMT-ST-42SSEG2. In the cables that will be connecting to this motor directly. So we've got let's see, the DB9 connector, so that's a little obvious. I'm just going to bring this a little bit closer, and we've got what we typically see on, let's say, the Cognex camera. So common sense would indicate that this is supplying some kind of power, and this is sending back the feedback of the motor, which is also true based on the location, right? So you've got some kind of an encoder here in the back, and that's going to send data to the control module, which is, or should be, in this package right here. What is inside? So we've got a few connectors that will probably go in this module. So here's the module in question, and we've got a manual. So before I'm going to go to the next steps of connecting, I'm actually going to look at the manual. I'm going to find the documentation online as well. So it should be fairly simple to connect this, as there aren't that many cables, but I do want to read up a little bit more on these different functionalities, because we do get the terminal blocks that plug into this module, and of course not all of them will be used for the drive. So we do need to confirm the voltage, we do need to confirm what other signals this may require, and of course if you want to read that yourself, you have the part number. So here's the module. I'm going to just rotate so that you can see the part number, which is CMMT-ST-C8-1C-EP-S0. And as you can tell already, the input voltage is going to be 24 to 488 DC, and it consumes 8 amp, which is actually quite a bit. So I'm probably going to have to install a dedicated power supply. All right, after going through the manual, I can talk about all the connections on this servo drive. So first and foremost, the servo itself is going to have the 2 connectors of the 2 cables that came in the package. First one being the M12 8-pin plug, and the second one being the DB9 connector. So the DB9 is indeed used for power, and the other one used for feedback. Setting that aside, let's look at the drive. So we've got several terminals here. The 2 main ones are going to be the X2 right here, and then the X6, the label for which you cannot see from this angle. Let me just put it up a little bit better. So what's really important is the pinout. So here the X2 is going to have 2 labels on the right hand side, which is 1 and 4. So the pins are going to be 1, 2, 3, 4. And then on the other side, you'll just notice that little 8 at the very bottom left hand corner. And what that really means is that starting from the top of that wire, that's going to be pin number 5, 6, 7, and then 8. So the color code must absolutely match the pins, and that's going to be specified by the manual. Similarly, you have a color code that's going to be for the X6 terminal, and here, as you can see a little bit better, the wires are slightly thicker. You will have an easier time to make the connection going from A to BR minus. These terminals are also very interesting. They are not screw terminals or push in. It is somewhat of a different type than what I'm used to seeing. So typically you would leave the screwdriver in. In this case, you're just pressing down on this little blue pin, and that opens up your terminal. So it is a type of a spring clamp terminal, but it is taking a little bit time to get used to. You cannot simply leave your screwdriver in order to land the cable. And then the last item that I do have on here on the front faceplate is going to be the X1A, and based on the color, you probably have suspected that this is a safety related terminal. And in my case, it has been jumped. As you can see, the jumper is going to be between the pins on your screen right now. And so essentially it's between 6, 1, and then 2 and 3. And that allows me to bypass the software startup requirement as well as the safety. So all I'm doing is providing 24 volts to all those pins. And essentially in a real plant application, you should be using the safety features of this drive, which are going to be located on this terminal and specified in the documentation. The last thing that you should be paying attention to on the front and the top are going to be the Ethernet ports. So here we've got the X18, and then on the top you've got 2 more Ethernet ports, as you can see here. The front one is going to be used to connect to our PC, and that's exactly what I'm going to do after I finish filming the segment. The other 2 are going to be used, as I had mentioned earlier, to either daisy chain these drives on the communication side, but also to connect to the PLC. So what I'm going to do is connect one of these Ethernet ports to the unmanaged switch that I have on my PLC network. And last but not least, if we flip this drive over, you'll notice that there's going to be a power strip as well. So this is going to be labeled as 48 volts, 0 volts, and 24 volts. So 24 labeled pinout is going to be the control voltage, and then 48 is what you can use to either drive the motor, or what I meant to say is you can use 24 or 48 volts in this case. You'll notice that I have a jumper between 24 and 48, which means that I'm using 24 volts to drive my motor, and that's going to be a setting in the software side. Now, last but not least, as you will notice, I have specified or selected a power supply of 10 amps. Of course, in a test environment where we're not going to have a load on this motor, you are not going to necessarily need 10 amps, but based on these specifications, you should be specifying something that is going to provide above 8 amps based on the datasheet. Before we can communicate with the drive, we're going to need to download and install a few software tools. So I'm going to open a new browser window and show you exactly where to find them. So in the search bar, you can either type in Festo Automation Suite download, and then you will find two different links. So you can either go and directly download Automation Suite, or you can navigate to Support Portal either by searching Festo Support Portal, or like I said, typing in the string and then clicking on the link right here. So the support portal is where all of the software and documentation will reside for Festo products. So in my search bar, what I'm going to search for is the part number for the drive. So this is going to be CMMT-ST-C8-1C-EP-S0. Here we have 3 versions available, and the one that we've received from Festo is the EP type. So I'm going to select that. That being said, the software is going to be the same for all 3. And if we scroll down to the bottom, you'll notice there's going to be multiple tabs. We need to go into the software one. And as I mentioned, we'll need to download 2 different things. The first one being Festo Automation Suite. So I can select file and language versions. And then notice that I am going to be downloading version 2.1.1.1. Pay attention to the differences maybe of the tool as it changes. So we're going to save Festo Automation Suite on our disk. Then I'm going to close out of this. And the second thing that we need is this Festo Automation Suite plugin. Notice that this is different from the Festo Automation Suite. The other thing that I do want to point out before downloading this is that the supported systems are going to be listed down here. If you're using a different drive, if you've purchased something different for practice or for commissioning purposes, make sure to download the drive that's going to be specific to your device. This plugin is going to enable us to configure the specific servo drive that I have in Festo Automation Suite. So once again, file and language versions, and I'm going to download once again the latest, which is 2.1.1.11. So this is a .fsi file, so this is different from the exe file that we've downloaded for the Automation Suite. Let's go back to the desktop, and I'm going to copy and paste both of those files. I'm using a virtual machine, so I'm going to move them to the desktop. Simply double click on the shortcut to begin the installation process. We're going to accept the license agreement, press on install. Once the installation completes, you'll notice a couple of things. We can press this finish button, but the new shortcut has been placed on the desktop, as well as the shortcut for the plugin has now received an icon, and that's because it is a file type recognized by Festo Automation Suite. We can launch FAS, and once it is launched, we will import the plugin into the software. From the main menu of the Automation Suite, we can do a couple of things, but first things first, we need to install the plugin. I'm going to select that menu, and here you'll notice that a couple of them are already pre-installed, but what we can do is install a local file by clicking on the shortcut and then browsing to our desktop where we've moved the plugin for the CMMT-ST. Press on open, and this should open a different software tool that's going to take care of the plugin and then reopen Festo Automation Suite. So let's give it a few minutes. All right, back to FAS. It is time to create our new project. We're going to select that option. And here we're going to select the device on the right hand side. So we have the Ethernet IP device. And based on the plugin that we've installed, we only have one device to select from. We can add device. It should be presented to us in the middle. If we double click, it will initiate the plugin that we've just installed. It's going to take a few moments the first time. It usually takes a lot less once you relaunch the software. At this point, we'll need to address a few more items. The first one being the path. So by default, the drive is going to have the 192.168.0.1 IP address, which means that we need to go into Control Panel and change our network adapter settings accordingly. Open Control Panel. And here we're going to navigate to Network and Sharing Center, and here change adapter settings. We should be able to find the adapter that is currently connected from the drive to our computer. In my case, it's going to be this USB to Ethernet adapter. I'm going to double click, select Properties, go into IP version 4 settings, and then set my IP address to be on the same network as the 192.168.0.100. So that's the IP address of my laptop. Press OK. Press OK to apply, and we can close out of this menu. Now, the next item is we can go through a setup. So I'm going to start a first setup. We can definitely go in the manual option as well, if you're familiar with the drive and have some different parameters in mind. That being said, we do need to select the components of our drive system. And the first one has already been pre-populated based on our selection. So we need to select the motor, click on this little plus icon. And from the menu, we need to select the motor that I have in question, which is going to be the EMMT-ST-C8-1C-EP-S0 This is going to be located on the back of the motor in case you're unsure which part number you're working with. I'm going to press apply. It's going to take a moment to update the drive configuration and allow me to select the next item on the list, which is going to be the axes. When it comes to axes, we don't have a physical device, so I'm going to select user-defined rotative axes. I'm also going to select this unlimited axes option, which will allow the drive to rotate indefinitely. Press on apply. Once again, it's going to update for just a moment and allow us to select the last component, which is the mounting kit. Press on the plus sign. Here, once again, we don't have any hardware connected in my specific system, so I'm just going to use the default user-defined. Press apply, press on next. Device settings, so we'll talk about this a little bit later, but we can select field bus. And supply voltage 24, as I had mentioned before, you can definitely use a 48 volt power supply for the drive. We're going to talk about this a little bit later as well, so the IP address is going to be configured down the road. Press next. Application data, I was told that specifying 0 doesn't make sense if you have no load. Typically, this drive would be connected, or the shaft of the drive would be connected to a load. So we're going to select this 0.01. Press next. We have no hardware switches in place. Homing method is fine. No software limits, and press on finish. So this is going to take a minute to calculate all the parameters, after which we can go online. Some of the parameters are going to be defaulted to a software base on Automation Suite, so we can go into all the warnings and essentially apply the recommended value by hitting this apply button, and all of the warnings have disappeared. At this point, we can connect to the drive by pressing on this blue connect button. So let's give the device a few seconds, and it should give us a prompt on whether we want to download to the device, if we want to upload from the device, or if we want to stay offline. If there are any discrepancies in the parameters between the Automation Suite and the drive, which we typically would expect there to be some once we are connected for the first time. So that's the only difference. We're going to write to the device maximum torque. We can certainly read a little bit more about this parameter from the manual. Write to device. Once we are successfully connected, you notice that there's going to be a check mark as well as a connected sign on the drive. We can now, in order to control the drive from the software, switch on this plug-in PLC control button. It will give us a warning that we are taking over the controls. I'm going to press OK, that's fine. And next, we need to enable the power stage. So we're going to flip that switch as well. And at this point, we do need to store the parameters on the drive once again if there's any discrepancies. So that should take just a second. And we have control of the drive. In order to make changes to the position, we can go into control. And we can start by homing the drive. You'll definitely not hear or see the drive right now. It's sitting behind me, but we do have full control. So we can start by jogging the drive. We can execute a move. So for example, in this case, we can get it to do 10 rotations at 240 RPM. If I press on execute, you'll notice that the position of the actual value is going to increment to that target position. And once again, if we go back to 0, we can execute and the drive is going to go back to its original home position. So this is pretty much it for the episode. Hopefully you have been able to follow along. If you have any questions, feel free to reach out. In the next episode, we're going to communicate between this drive and a Allen Bradley Compact Logics PLC, and I'm going to be showing you once again in very detailed steps on how to interface from this Festo drive to the PLC and being able to control it over Studio 5000. And I'll see everybody next time.